Okay, here is a optimization problem example. It's maximum volume of a rectangular solid with square base. So I guess we'll start by drawing this thing. It's going to look like a box. So that's always a good idea to draw it. So what we're trying to do here is figure out the dimensions that result in a solid with maximum volume. So this is the key word. We're trying to maximize volume. That's how you know where you're going to get your primary equation from. So before we start, let's see what we can get from the text here. It has a square base. So the base of this solid, usually we call it like, X, Y, Z. Since it has a square base, let's call it X, X, and then how about the height Y? So that's what we're looking at. Um, we're trying to maximize the volume, so the primary equation would be the quantity that we're trying to maximize, or volume. So now we just figure out what the volume of this box is, and that would be base times width times height. So now when you look at your primary equation, the independent variable is volume because it depends on what the lengths of the sides are. The dependent, I'm sorry, I said that wrong. The dependent variable is the volume because it depends on what the lengths of the sides are. So X and Y are the independent variables. We have too many. To maximize this equation, we're going to have to uh, rewrite it with one independent variable. So we need a secondary equation, and that comes from the rest of the information. The surface area of this box is 337.5. And surface area of a box would be just the sum of all the areas of all the sides. So these two sides and the two opposite would be an area of x times y. So there's four of them. And then we look at the top and the bottom of the box for the other two sides. They both have a area of x times x, or x squared for each. So we just summed up all six areas of the cube. Well, not cube, I guess, box. So now we have to write one primary equation with one independent variable. So we're going to use this to solve for either x or y. And it looks like here the easiest thing to do would be to solve for y, because there's two x's here. It's going to be tough to get them by themselves. So I'm going to say y would equal 337.5 minus the 2x squared, and then divided by the 4x. So that looks like a mess, but let's see what happens. Our new primary equation, which would be the one with now only one independent variable, which would be obtained by plugging y in for the y, would be x squared times y, which we said is 337.5 minus 2x squared all over 4x. So we've gotten our equation. Now we just have to find the min or max. And we're looking for a maximum volume, so we have to find out the dimensions that will produce a maximum V. So just like all other maximum and minimum value questions, you're going to have to figure out the critical numbers of this and determine if they produce a max. So this is, now you just go as you've learned in sections before this. So we're going to finish it. It looks more complicated than it is because you can see that x squared, and you're multiplying it by this mess over 4x, you can cancel out those x's. So, and that 4 is just a constant, 1/4. So when you cancel this x with this x, you're left with this. And then because we have to take the derivative of this, it's going to be easier just to multiply that x through and start from here. So the derivative of v would be 1/4, that's a constant, times 337.5 minus 6x squared. And now we're going to set this equal to 0, find the critical numbers. X squared is going to be 337.5 over 6. So x would be plus or minus the square root of that fraction. I'm going to use the positive because of the domain. Being that this is a box, the length of the side is going to be positive. I'm going to break out the calculator on this one. The square root of 337.5 over 6. Screwed that up. What I meant to say is square root of 337.5 over 6 is 7.5. So that worked out nicely. That must have been there's perfect square under there or something. So now it's asking for dimensions, but first of all, we have to determine, does this actually produce a maximum volume? So I'm going to use the second derivative test. This critical number of 7.5 should produce a negative volume. So here's the first derivative up here. The second derivative is going to be 1/4 times a negative 12x. So this would actually be, if you plug 7.5, that's going to be a negative. So that would be a relative maximum. So now you should check to see if it's an absolute max. I won't go through that here because I want to show you how to check this. But first of all, we haven't answered the question. X is 7.5. We need to get Y to get the dimensions. We're going to plug it into here. So here we go. We have, actually, I'm going to plug it into here. It will be easier to type. 1/4 times 337.5, 337.5. I did the same thing. Bear with me for a second. 0.25 times 337.5 times 7.5 minus 2 times 7.5 squared. Sorry about that. Minus 2 times 7.5 to the third. And this is wrong. I'm sure. Oh, that was the volume. I plugged it into the wrong equation. Like I said, I should have plugged it in here. Um, so plug it in there. You do that because I don't want to waste your time here. I do want to show you how to check though. So all we're doing is trying to figure out what the maximum volume of this equation is. So on your calculator, if you type that into y equals 0.25 0.25x times 337.5 minus 2x squared. Okay, this is the original equation, so the maximum should be right up here somewhere. It's a negative cube graph, so it is starting up, going back up, and ending down. So the maximum, if you can see my clicker, is up here somewhere. You can zoom out if you'd like to have a better view, but here we go. Second calc maximum. I can see that the maximum is somewhere between 0, so 0 on my left bound, and over here it looks like, I don't know, we're around, if those are right, I'm just going to say 10. So that should do. Hit enter for a guess, and you see how it says down at the bottom x equals 7.5. And the volume is 421.875, which is what I was calculating by mistake here. So maybe that was a good 421.875. Maybe that was kind of a good error because you can see it will calculate the actual volume and the x value at which it occurs. So I hope that's useful to you and you don't mind the mistakes. And I will see you during the next video. Thanks for watching.